Hello, let me try to understand this problem. So, given an integer n, return the number of prime numbers that strictly less than n. So, it's clearly that the input would be an integer. When we see the constraint here, so we can see that integer is non-negative, so its integer is greater or equals than 0. And the output of this problem would be the number of prime numbers. So strictly less than n. So let me do an example. For example, 5, n equals to 5. So what we are doing here is we are going to check whether they are prime numbers, the prime numbers that are strictly less than n. So I'm going to check 0, I'm going to check 1, check 2, check 3, and check 4. We don't check 5. So here, 0 and 1 are not prime numbers. So this is number and it's prime. So it's not false. False. 2 is a prime number. 3 is also a prime number. 4 is not. The prime number is a number that is only division by 1 and itself. So I think I understand the problem, and now let me try to match with some previous problem. Like this problem is pretty much like a little bit similar to the Fitzgerald's problem, and it's also pretty clear that there's going to be a for loop to check each one of the number whether they are prime numbers or not. So it will be also a for loop. And let me try to plan out. And actually, I also learned that there's a algorithm. C for something else is used to do this problem. So actually, let me try this. So for the first part, I'm going to start with prime numbers and then go through to figure out. So it seems that I need a list that contains all the numbers I'm going to check, and then I need a way to mark whether they are prime or not. So it's really easy to use a Boolean number to mark them. So the first step, I'm going to create a Boolean list. So it will have a length of n because it includes all the numbers that is strictly less than n. So for the next step, I'm going to start with I'm going to do the for loop. So I'm going to do the for loop, and then I'm going to start with prime number 2, and then I'm going to mark the multiple of 2 to be not prime, to be false. So in the Boolean list that I initialize should be true. So the basic assumption here is that I create a list that all the numbers are assumed to be prime numbers. So and then I start with the prime number 2, and then mark multiples of 2 as not as false. And then I go to the next number, next prime number. So and then go to the next prime number and do the things again and again. So the for loop should start with 2 and then end with n over 2, because when you go over n over 2, all the numbers that are marked prime is going to keep prime, because you are not going to mark their multiples as not prime because they are out of the range. So this is pretty much the for loop. And then after the for loop, I'm going to output the number of primes. So I just need to output the number of prime. So in other words, it's the number of true in the Boolean list. So that's pretty much the plan. I'm going to try to implement it. So let me try to implement this. So first of all, actually, before I create a Boolean list, I need to take the input, right? So the input here is already here. So n is our input. So actually, I can skip that step. So start with step 1, create a Boolean list. So I will call this is prime list. So is prime equals to a list that is true, and I will have a length of n. So I'm going to start with the for loop. So just remind that 0 and 1 are both they are not prime numbers. So actually I should do this. If n equal to 0 or n equal to 1, I will simply return 0 because they are not prime numbers. And then start with 2. So I'm going to, for I in range, I will start with 2 and end with n over n divided by 2. And then, so what I'm trying to do here, I need to mark all the multiples of 2 as false. So I also need a loop or while loop or for loop to do that. So let me try to do it in a for loop. So for j in range, starting from 2, so it starts from 2, no, start from 2 plus 2, 2 times 2, okay. And I'm going to end with n. The step will be I. So this should be I times I, or I times 2. So in that case, I'm going to mark them as false. So it's prime j. I'm going to mark them false. So after I mark them false, I will go to the next prime number. So how do I know that it's a prime number? It seems like I need a if-else statement to do that. So if it's prime I, it is true, it is a prime number, so I will do this. If not, so if it is a prime number, I will do this. I will mark the multiples as false. If not, just go to the next number. So it seems like I have done all the things, and all the things I need to do is return something, return the number of true. So since false are 0 in the list actually, so the only things I need to do, I just need to sum up the is prime. There's a problem. I return 0 here, but it seems that I need to do this. I need to mark the first and the second. 0 and 1 is not prime. So let's continue. So I think that should work. So it seems like it's not happy with this one. So I think it's double slash that is integer division will solve the problem, I think. So let me see whether it likes this solution or not. Okay, good. When I submit it, oh, wrong answer. Expected 2. So what happens here? So n equals to 5. Why is output 2? So maybe I'll try this. All right. It seems like there's something wrong with that division. So let me do a quick review of my solution. So I actually create a Boolean list, which takes up all of n space complexity. And I do a for loop here. So it is a for loop from 2 to like n over 2. That's pretty much the all of n time complexity for the outside for loop. And for the inner one, it's going to have uh, kind of like a log n time complexity because it has a step of I. So I think that's pretty much it. It seems like there's something I can improve here. For example, maybe when I go through the inner for loop, some of the numbers have already been marked as false. Maybe there's a way to improve here. I think that's pretty much it. Thank you.